Okay, so now I'm back. Alright, so we're stopped at, we had 3 non-collinear points. So whenever you're asked to name 3 non-collinear points, then you're asked to name them. You don't put them together. So we have BC, E, BAC. We can also use DCA, DCA, or what else can you think of? DCE. You can use either one of those, so it'll be correct. Now three coplanar points on here. So which points are on it all on the same plane? So anything that's on R, we can use either BCE, BCE, ECD. We can use BCA, DCA, because they're all on the same point. They're all on the same plane. They're all on B. These are also on plane R, on the red plane. So 3 coplanar points to be, let's go ahead and use for, on the red plane we can see B and C are on it, and we go with E. Now on the blue plane we can go ahead and use D, C, and A. D, C, and A. Or we can use BAC that are on the blue plane. So see this cursive letters, this is what the cursive letter for the blue plane will be. N, plane N, and this one would just be plane T for the red plane. Alright, so that's pretty much it for 1.1, and a little part that I'm going to cover is the whole idea of notation. So notation is just a way of actually describing geometry sense. So capital P, X and Y with 2 arrows on top, that would just be a line. Plane ABC, plane M, signify what a plane is. Notation for a segment would be AB with the bar on top, or BA with the bar on top, where A and B are both endpoints of a line. Now, array would just have one endpoint, and it's pointing in one direction of one particular point, and it keeps extending out for forever. So then an opposite array may look like this, but if you're asked to name a pair of opposite arrays, then you're supposed to name each individual array. So UV pointing in one direction, and then UN pointing in the other. Okay, so collinear would have all 3 points are on the same plane. On the same line. Or coplanar, where all points are on the same plane, just like we have over here. Not E. And will be an example of a non-coplanar point. Now here, segment addition postulate is something we're going to work with, and I believe it's 1-2. I believe it's 1-2. So whenever you heard the phrase, if B is between A and C, then AB plus BC is equal to AC. So that's just saying that we have points A and C, and B can be somewhere in between, but it won't be at the halfway. We don't know if it's halfway. So we can say that this is not equivalent to that. So we can say that the total length of this is 1, 2, 3 ticks. So you can say 1 tick plus 2 ticks gives you 3 ticks. Okay, so this would be A to B, and then the 2 ticks will be from B to C, and then 3 ticks will be from A to C. So we have up here. Okay, so it would be 1 tick plus 2 ticks equals 3 ticks. So that's just one way of seeing it. Now here, you're gonna look later on in the section where you have difference between, well, we can see PQ is equal to RS, and then you're able to see this part. So we're going to try and determine what the difference between this one and that one is. So right here from PQ and RS is just giving us what a length is. It's just giving us a length. We know that the length from PQ is equal to the length of RS. Now let's go ahead and use our notations here. So we have segment PQ is congruent, which is this equal sign with the little squiggly sign on top of it, is congruent to segment RS. Okay, and that will be it for 1-1. So yeah, so like I'll see you in the next video.